What is a seismic wave?
Obviously, it is the vibrations generated by an earthquake, explosion, or similar energetic source and propagated within the earth or along its surface.
Oh, wow, I didn't know that you do that. Did you know that you can better understand the Earth's structure with them? Today, we're going to talk about the woman who used math to better understand our world.
Ew, math. I hate that you do so many math and physics episodes. I'm not gonna lie.
Oh my goodness.
Yes, yippee for women, but I don't like math. I
Okay.
understand that this M in STEM is math.
Yeah.
Wait, is it for math or is it for mechanics?
It's for
math.
math.
Okay, but I still don't like it. Just STE. I don't need STEM. Just STE.
Oh, that's funny. Well, we don't really go math in this. It's more cool. It's more like world-esque. So
Okay.
I think you'll like it.
Yippee.
So
Intro.
today's woman is Inge Lehmann, and she was born on May 13th, 1888, to Ida Torsleff and Alfred Lehmann, who was a professor of psychology. It is said that she is a very shy girl who hated being in the spotlight. It's also noted that she was like that her entire life, so like same. Inge grew up in Copenhagen and, interestingly enough, went to a high school that treated girls and boys equally, which was obviously like a very progressive idea at the time. The school's name translates to, quote, shared school, and was branded, or it was brand new when Inge went to it. It had been founded by a wealthy woman named Hannah Alter. Of course, it was founded by a woman and therefore was equal. I'm joking, but that's probably why. I think it was based on her like standards of what she wanted education to be. But anyway, so Inge liked school, but it is noted that she often felt bored and not challenged enough when she was there.
In 1906, at the age of 18, she passed the entrance exam for Copenhagen University with a first rank mark. So I'm assuming she like basically did the best she possibly could.
Yeah.
And then in 1907, Inge began to study mathematics at the University of Copenhagen with the goal of getting the equivalent to basically a master's degree at the time. From the fall of 1910 to December of 1911, Inge attended Newnham College, Cambridge, but ended up returning early to Copenhagen after low-key, like, overworking herself like crazy.
Yeah, so in between 1911 and 19 okay, I said that right, my bad, and 1918, during those 7 years she took a break from school and worked as an actuarial assistant at an insurance company. So this was like the most math part of her life, honestly. She basically assisted a business professional by using math and statistics to analyze financial risks and build financial models.
I'm like low-key surprised like how many jobs you can get with math.
Yeah, when I was in like college and we heard people majoring in math, I was like, what are you gonna do with that? But
Become a math teacher. That's all I thought the people with
Same.
math degrees did.
But that is very wrong. People with math actually do a lot.
Yeah. A lot of them are like they have like similar positions to like computer science.
Mm-hmm.
Like honestly, I've like looked at it and like obviously like comp sci is more like computer based and like math is more like statistical, like modeling based, but like they do a lot of the same stuff.
When you have beep beep boop boop due on Friday after. I sent that meme to my brother last night because he's comp sci.
Yeah. Me, then I have my 1, 2, 3, 4s.
Yeah, exactly. Okay, yeah, so she actually returned back to the University of Copenhagen after this brief period of being math human in 1918 and finished her master's in mathematics. So she actually just went to do more math, and she finished her master's in mathematics in 1920. She continued to study mathematics at the University of Hamburg during 1922 before starting another position in the actuarial science department at the University of Copenhagen. Whoever she worked under, some like professor guy, he showed her how the internal structures of the planet can be seen via earthquake data and math.
Huh.
So
interesting.
Yeah.
So in 1925, she became an assistant to the head of the Royal Danish Geodetic Institute. I think that's how you say it. But part of her job involved setting up Denmark's first seismic station near Copenhagen, Greenland. Ivigtut. Oh my god, this one's worse. Itorkentorndemit. I'm like genuinely not trying to butcher it. I just don't know how to say it.
Yeah,
Ittokqortoomit. Itorkentormit. Anyways, so because of her growing interest in seismic things, she re-enrolled in the University of Copenhagen and studied seismology. Yeah, so she did that during the summer of 1927 and graduated with a Master's of Science in 1928 when she was 40 years old. Also in 1928, Inge became the state geodesist. Can we not just say geologist? Geodesist.
It's probably well, I guess it's not geologist because she's like math core.
Geodesist.
I don't really know, but sure.
Meaning that she measured and monitored the Earth's size, shapes, tides, polar motion, and gravity field to create accurate coordinate systems and models.
See, that's more than a geologist.
Yes, most definitely. Do you know that a lot of geologists will just like lick rocks to tell if their rocks are bone?
No, but what if you lick a bone and then you're like, oh my god, a bone, like...
Well, if you
really
lick a bone, it
icks me
just
out.
like sticks to your mouth.
Ugh.
So if you go to like spit it out, it won't
Dude,
come
the
out.
like microbiome in me is like...
I told Cameron today that I eat my steak really rare, and he said, "You understand microbiology. How do you do that?"
That's not how it works. Okay.
Anyways, but Inge was made head of the seismological. There's a lot of big words in this podcast today. Seismological department of the Royal Danish Geodetic Institute. And then she was head of that department until her retirement a lot later in 1953.
Yes. The majority of her work at the seismological department involved managing the seismological stations in Denmark and in Greenland, as well as collecting seismograph information and creating the bulletins associated with the stations. She quickly became interested in determining the location of earthquake epicenters more accurately based on the data provided by the seismographs. She did this by correlating the primary seismic waveforms collected. She was also interested in calculating the travel times of various types of seismic waves through the planet.
In 1929, while looking at seismograph data collected after a large earthquake in New Zealand, Inge noticed that seismographs stationed in the Russian cities of, you gotta be kidding, Yekaterinburg, and Irksturks.
Oh, yeah.
Can you pronounce those?
No.
Okay.
They're in your paragraph for a reason.
But you spoke Russian.
Past tense.
Anyways, those two Russian cities collected seismic waves with amplitudes that were a lot higher than she expected. She also discovered that there were some waves traveling away from the earthquake's focus and appeared to have been bent. The waves obviously weren't bent. Well, I mean, like, they were, but they weren't. Anyways, at the time, it was known that the Earth's core deflected secondary, or S waves, and some primary, or P waves. S waves travel transversely. This is transversely, and this is longitudinal. So S waves go like this, P waves go like this. And if you are listening to the audio version, good luck. But this creates shadow zones behind the core as those waves traveled outward from an earthquake's focus to its antinode on the other side of the planet.
I don't really understand what half of this means, to be honest. It sounds fake.
It's
It's real, but it sounds fake.
I remember being in physics and shaking the string, and you'd see the different
yeah, that's about the extent of my knowledge. But yeah, so the time that these S and P waves take to travel from an earthquake's epicenter to the different seismic observatories, around the world reveals information about the paths the waves take. The path of the earthquake waves through our planet depends on the materials the waves travel through and the boundaries between these materials. So, fun fact, at this time, roughly since the 1880s, geophysicists believed that the Earth was made up of a liquid core surrounded by a solid mantle, which was then surrounded by a crust. So it's pretty much like all liquid, and then there's like a little solid outside, is what they're trying to say. And this like was basically separated, like the liquid and solids were separated by abrupt density changes in the Earth called discontinuities. So they were obviously wrong about the first part, but the second part I think is still kind of believed today.
So in 1906, Richard Dixon Oldham analyzed seismic waves from several earthquakes and concluded that the Earth has a large liquid metallic core. He calculated the size of the core roughly that it forms the inner 40% of our planet's radius. Even though scientists now knew that the Earth had a core, seismologists still didn't fully understand the meaning of the data recorded at the observatories. While studying the large New Zealand earthquake, she saw a few P waves recorded, even though they should have been deflected by the core. At some point, scientists learned that S waves do not travel through liquid, but P waves do.
So Inge was like puzzled at the behavior of the P waves because they were not traveling through the Earth like they were supposed to. Inge theorized that these waves had traveled some distance into the core and then bounced back off of some kind of boundary or something. So Inge was like, okay, I have an idea. People believe that the Earth was, what did they believe? Oh yeah, so they believed that the Earth below its solid crust was molten liquid. It was just liquid. And she was like, I wonder if Earth's inner core might actually be solid. If it were solid and then surrounded by a molten liquid, that might make more sense. In 1936, Inge published her findings in a paper about a 3-shelled model of Earth's interior, made up of the mantle, the outer core, and then the inner core, with seismic waves traveling through each shell at different but constant velocities. The model included Earth's core, but suggested the existence of an inner core as well. She theorized that the inner core was solid and that the outer core was liquid. She developed mathematical models that she included, which made perfect sense with her theory. By the way, this is like kind of cool. Her paper was titled very simply P, because the P waves were weird, so she was like, I'm calling this P.
Interesting. She like, that was it? Like, if you looked for like something on a shelf, it would just be P?
Yeah. Just the letter.
I fear if that was like published in like modern times, it would not do well because like someone's like searching up like seismology or like earthquake and the like P would not show up.
Like, I guess so. I don't know. I don't know anything. Like, I'm not in the world of math or physics or geophysics, so like, what if it's a big thing? They're like, oh my god, P wave.
We have to name things like
What if there's like other books named like S and like X and just variables?
And they're just naming them X and Y.
I feel like it could go either way. It could be like a super cool like niche cult and everyone's like, do you know about what this is? And people are like,
just a secret
what?
code.
I need to know. Or it could be like, why did you name that P? What is that? And no one will ever find it.
Honestly, that sounds very Kate core. Sounds like something Kate would do.
I feel like Kate should be a physicist.
I would agree. She enjoys physics quite some.
Yes.
But back to Inge. So, it wasn't until 1970 that advances in seismograph technology were able to 100% prove that there is actually evidence of an inner core, confirming Inge's hypothesis. The boundary between the inner core and the outer core, which occurs roughly at a depth of 3,200 miles, is named after Inge. It is called the Lehmann discontinuity. Inge is also known for researching Earth's mantle. She retired from her position at the Geodetic Institute in 1953 at the age of 65. She was now free to research in the US and in Canada. In 1954, she was working with an American seismologist named Bruno Gutenberg when she noticed the existence of a region in the Earth's upper mantle where seismic waves were traveling faster. That region, which spans about 31 miles, is also known as the Lehmann discontinuity. So there's 2 Lehmann discontinuities. That's strange.
I couldn't really figure out, and I think this is just because I don't really understand this topic very much, if it's like every discontinuity that there is, and there's only a couple of them, or all like, this is a Lehmann discontinuity, and this one exists here and that one exists there. Like, I don't think there is a bunch of other ones.
I see. So it's like where like waves basically behave strangely is a Lehman discontinuity.
I think so. Or there's some type of boundary, and that boundary
I
could be like,
see.
oh, now we're approaching liquid to solid, and therefore there is a boundary of
I
XYZ
see.
where it's like in between or changing.
Interesting.
Um,
Well, this upper Lehman discontinuity happens about 120 miles below the Earth's surface. It's crazy because, like, imagine driving from, like, here to Columbia, but instead of driving from,
You're,
like, physical, you're driving,
going
like,
down.
down, and then, like, you're, like, dead. Because you're molten.
I mean, yeah, I'd be dead pretty fast, but imagine you didn't die and you could just keep going.
It's so cool.
It's giving, Magic School Bus.
It's giving, I can dig a hole to China.
Oh my god.
But yeah, so the discontinuities were discovered like when she was like low-key in retirement, and like people still don't really understand what they are. Clearly, we don't understand what they are.
So it's like really crazy is that like I kind of forgot that like she did not have a computer to do any of this with. Computers do not exist.
Yeah, she had to do all the math herself.
Yeah.
Oh, that's crazy.
Yeah, this is wild. Well, instead of a computer, she had a bunch of oatmeal boxes. So in the boxes, she would use, I think from what I understand is that she would use them like filing systems. She would have like a whole bunch of like cardboard cards with information on each like individual earthquake from all over the world. So she had like a whole bunch of boxes with a whole bunch of cards in them, and each card would be a different earthquake. And before computer processing was available, she would basically like do all of that herself. She would like file everything, and then she would register the velocities of propagation of the earthquakes and then compare them with all the other cards and like cross-reference everything to like do whatever she was doing make sense, because I don't really understand what the heck she was doing. But so this way of like looking at it with all her cards and the oatmeals would like help like the data make sense to her in order to deduce new theories about the inner parts of the earth, because then she could kind of like look at everything all in one place instead of being like, I don't remember what happened in New Zealand that one time.
Interesting.
But yeah.
So, in addition to these discoveries, Inge co-founded the Danish Geophysical Society in 1936, and then headed the organization in 1941 and 1944. She was awarded the William Bowie Medal of the American Geophysical Union in 1971 for her contributions in the field of geophysics, and received the medal. Sorry, that's a lot. She also received the Medal of Seismological Society of America in 1977. Oh, good God. The American Geophysical Union created the Inge Lehmann Medal in her honor in 1995, and starting in 1997, it was awarded to researchers who displayed outstanding contributions to understanding the structure, composition, and dynamics of the Earth's mantle and core. That is a very specific award.
Yeah. She must have inspired somebody. In 1971, when she received the William Bowie Medal, which, by the way, it's like the highest honor that the American Geophysical Union can give, Inge was described as, quote-unquote, the master of a black art for which no amount of computerizing is likely to become a complete substitute, which I think is interesting, especially in our day and age, because we have so much like AI taking over everybody's job, and I think it's easy to forget sometimes. Or not. It depends on which angle you're looking at it, that like using an AI tool is not always the best method. You're not going to get the best amount of work because it's not really like another person thinking in there. You're not going to come up with new things. But yeah. So during one conversation with her nephew, they were talking about her like struggles against the male-dominated research community, and there's not a whole bunch recorded except for this conversation because her nephew like loved to talk about this woman. He's why we know of the oatmeal boxes, by the way. But it's recorded that she said, "You should know how many incompetent men I had to compete with in vain." That's the only sentence about that we have from her, so I guess you kind of have to infer a little, but I mean, it would make sense at the time. Also, like, I have no idea why, but I found out that they named a beetle species after her in 2015. It's named the Glabicornis, in parentheses, I guess that's like the species or whatever, Hadrotoma, and then the last specific part is named after her, Inge Lehmann, A. So, she got a beetle named after her.
Interesting. Did she like beetles?
I have no idea.
That's so strange. Well, in 1987, at the age of 99, I was like, she was born in like the 1800s. She has been living a hot minute.
Yeah.
She's been alive. So yeah, she was 99. She wrote her last scientific article titled Seismologies in the Days of Old. In 1988, she attended the party held for her 100th birthday at her old workplace, the Geodetic Institute. She lived to be 104 years old. That is crazy.
Yeah.
She did not marry, did not have any children. She left her possessions to the Danish Academy. And later in life, she recalls her first experience with an earthquake.
I didn't really know what to end on, so we have this from her. She said this when she was like very old. She says that when she was about 15 or 16 years old, when on a Sunday morning she was sitting at home together with her mother and sister, and the floor began to move under her. The hanging lamp swayed. It was very strange. Her father came into the room and said, "It was an earthquake." The center had evidently been at a considerable distance, for the movements felt slow and not shaky. In spite of a great deal of effort, an accurate epicenter was never found. This was her only experience with an earthquake until she became a seismologist 20 years later.
The end.
Yeah. So she did a lot with her life. She dedicated her entire life to research and earthquakes, and I don't know, it was pretty cool.